So here is an example of a pre-response question from an old AP exam that deals with projectile motion. So this would be from Unit 3. Only parts A, B, and C deal with it, so that's all I'm going to show you here. So we have our question, and we've got projectile launched from the top of a cliff above level ground. It's 35 meters above the level ground. Velocity initial is 50 meters per second, angle of 37 degrees above the horizontal. Air resistance is negligible. So first thing that we're asked to find is the total time that the projectile is in the air. So I've got my diagram here since I'm on a different sheet of paper. But ultimately, I wanted to use this equation here. And you actually got a point on the AP rubric for stating this equation that you're going to use. And you also got a point, I believe, yes, you got a point for solving for the correct initial y velocity and using that component. And then you got a point for actually stating how you plugged into the problem, and then a point for the correct answer. If you were to look up this solution, you would actually find they used 10 for gravity because the AP exam used to not allow you to use a calculator. But if you use 9.8, you get 7.12 seconds. And they would have given points for that equivalent. Then for part B, you're asked to find the horizontal distance that the projectile travels. This again is 3 points. You get a point for using the correct equation, a point for plugging in the correct x value, and a point for the correct answer. You might be tempted to use this equation, and I just wrote this here so that we know that you cannot use this range equation because the only time this equation is valid is if your initial and final elevations are the same. And that's not the case here. You're up on the cliff, you come down below the cliff. Then for part C, you're asked to find the velocities at points A, B, and C. So let me show you that diagram again. At point A, you have no y velocity, but the projectile is still moving in the horizontal direction. So your only velocity is the x component of the velocity, which you see I give right there. Okay? Then for part B, because this is symmetrical, you're going to have the exact same speed that it left with, that it left the cannon with. The velocity is going to be in a different direction, but the speed is still going to be the same. So I did that. Then for part C, which is where they gave the majority of the points, I believe they gave 2 points for part C, 1 for part A or points A and B. Down here, you have x velocity, you also have a new y velocity that you have to find, and then you need to add the 2 components together. So you can see my work here. I found my new y component of the velocity by using this equation, plugging in here. And then, if you needed to see a visual representation, you would still have your x velocity of 40 meters per second. And now you also have a component of 38.6 meters per second downward. And so our overall velocity is going to be this right here. And that's what we need to find. And so we use Pythagorean theorem to find that. And this part right here is our final 2 points for that part of the pre-response question. So hopefully this lays things out for you, shows you an example. There's not a whole lot of just projectile motion, but they do pop up here and there for part of a question.